Hey guys, talk about radical equations. And radical equations are equations with what you'd be familiar with to just saying square root symbol. Okay, it's an equation in which a variable appears in a radicand. And let's see. Hopefully y'all remember. This is my square root symbol. There's an understood 2 to be written there. Okay, this is called the radical, and inside whatever's there. So I will just put, let's say, 4x. That is the radicand. The number that's out here, and again, if there's no number, there's an understood 2. Square, anytime we're talking about square, we're looking at the number 2. Uh, this is called the root index. So I'll make it a cube root. I'll put a 3 there. We have to write a 3 whenever it's not a square root. Whatever number it is, we have to write it. And the other takeaway for this to remember, instead of writing, say, like the square root of 16, I can write this 16 to the 1/2 power. And you can check that on your calculator. Both of those will equal 4. With your calculator, you may need to put parentheses around it whenever it's a fractional or a rational exponent. All right, so let's take a look at how this works out. Principle of powers. Okay, and this is part of what I mean about critically think about what you're doing, because everything in math makes sense. There's logic behind and a set of steps behind what we do. It's just not arbitrary. So if a equals b, then a to the nth power equals b to the nth power, where n is a positive integer. Okay. Now, what it is we say, well, that's silly. I can see that if A is 2, then B is 2. So, but where it gets more complicated is whenever we make up our equations. Okay. Something like this. Whenever I say the square root of 3x plus 1 equals 4. Well, we're going to take that and apply that. We can view this as being A and 4 as being B. And we're going to apply it. So, here's our problem. I have the square root of 3x plus 1 equals 4. So what I'm going to use is the principle of powers. Again, I'm saying A equals B. So what I'm saying is this right here. This is like A and this is like B. And what I'm saying, if I take them both to the same power, as long as it's a positive integer, then my principle of powers tells me I'm going to be able to solve for it. The other way to look at it, and again, this is depends upon how your brain works. This is a logical way to think it through, and if you can reason like this each time, honestly, it really simplifies your work. But if I have a square root symbol, how do I get rid of it? I square. What I do to one side, I have to do to the other. And it is the same with an equation. To get rid of something that's multiplying in the equation, you divide or multiply by the reciprocal. If there is addition going on, you subtract. If there's subtraction or a negative number, then you add. So, same premise. Since there's a square root symbol, I'm going to square. If I square this side, I must square the other side. So when squaring both sides, I now just have a basic equation. Two-step equation. Subtract 1 from both sides, and then divide both sides by 3. I end up with x equals 5. With our rational equations, we had to plug in, we had to verify our solution to make sure it's true. The same is for radicals. Because if we end up with the negative number inside of, in our radicand, after we solve it's inside the radical, then we end up with an imaginary number. So, we have time in this video. We verify, and yes, 4 equals 4, so x equals 5 is a solution. Let's look at the graph for that one. Okay, now I put it in there differently because the way Desmos reads it is it doesn't want an equal sign. It wants it to just be to where f of x equals the radical 3x plus 1 minus 4. So that's how I have it entered in, and we'll look at the graph and we'll see, and look at where 0 is. It is at 5. Okay, so let's look at another example for you guys. Here's another example for you. Okay, so you have square roots and cube roots, and then after that you there's not a particular name for it. So this is just the fourth root. That's the number 4. So the fourth root. So I will use the principle of powers. And again, this is A and this is B. So I know that A equals B, therefore A to the nth, therefore A to the nth equals B to the nth. So I take both to the fourth power. That cancels out that radical. I'm left with what was the radicand, just right there. 1 to the fourth is simply 1. Now I solve for x. X squared equals 2, so x equals plus or minus the square root of 2. I plug those in and solve, and I see that both are solutions. So let's look at the graph for that. This is how I had to type it into Desmos. Look, I used, instead of the radical symbol to the fourth root, I put in just an exponential power of 1/4. Again, it doesn't equal 1, so I pulled the 1 over. So if you're having trouble seeing this, just understand that this is the same as the fourth root, and then all I did was I subtracted 1 from both sides of the equation. This is what this graph looks like. And if you will look there, let's see, that is the value of square root of 2 and a negative square root of 2. Notice there are no values in between -1 and 1 for the domain, because it's less than 1. Therefore, under the radical in the radicand, you would end up with a negative number, imaginary numbers. So no solutions in between those two. My domain is a union, and my range starts at a -1 and goes to infinity. Okay, so there is the graph for that equation. Now, and I'm showing you the graphs to help you to be able to visualize, to see, okay, this is what I'm doing. All right, so here's an example. I want you to pause the video, and I want you to see if whenever you solve it, we end up with the same answers, and hopefully we do. So go ahead and pause the video and see what you get. All right, this one here is a little different, so hopefully you thought about it critically. You probably saw, okay, well, let me square this, and then you realize, oh my goodness, this is going to be a hot mess. I'm multiplying two radicals together. And to be honest with you, as you move up through math, I do not even use these symbols. I make everything fractional exponents as I work through. But for showing y'all the simplest way to work it, what I'm going to do is I'm going to rewrite my equation. I'm going to get these radicals apart, and I'm going to try to only deal with one radical at a time. So I'm going to have the square root of x minus 3 equal to 5 minus the square root of x plus 2. We'll use the principle of powers and square both sides. I'm going to square that, and I'm going to square that. This simply becomes x minus 3. Now what I'm going to do is I'm going to rewrite this so I can visualize it. And all this means, that squared means I'm taking this and multiplying it by the same thing. So I have x minus 3 equals 5 times 5, 25. 5 times the negative radical x plus 2 is simply minus 5 times x plus 2. I end up with the same thing again because I'm multiplying the same thing. And then whenever I multiply these two radicals together, it's just like squaring. They're the same value. So a negative times a negative is a positive, x plus 2. Again, with this one right here, let's just say that this is a negative 2 times a negative 2, or sorry, a negative 4, radical 4 times a negative radical 4. Well, whenever I multiply these together, it's the same value. It's the same as saying this squared, right? My answer is just going to end up being 4. Well, if I actually solve this, that's a negative 2 times a negative 2. What's a negative 2 times a negative 2? 4. Okay, so back to our problem. I'm going to combine these two terms, and that gives me a negative 10 radical x plus 2. And then I'm going to rewrite and combine the other terms here. 2 and 25, it gives me 27 minus 10 radical x plus 2. And let's see, plus x. Can't forget that one. Alright, now what I'm going to do is I want to get everything else away from this radical. So I'm just going to do one step to save time. I'm going to subtract 27. I do it both sides. And I'm writing this out so y'all see it. Now I'm going to subtract x. X's cancel. I'm left with a negative 30 equals those cancel, those cancel. So I'll rewrite it up here. A negative 30 equals a negative 10. Divide both sides by a negative 10, because again I'm trying to isolate this radical so I can square it. That becomes 3 equals principal of powers, a equals b, therefore a to the nth equals b to the nth. So I'm going to square both sides. Square, square. It becomes 9 equals x plus 2. X equals 7. Okay guys, that was radical equations. Again, due to lack of time, what you need to do is turn around and plug this back in. I can look at this and see, okay, no negatives for the radicand with that value, so that solution is good. Verify your solutions. Watch the publisher's videos, please. Critically think about what you're doing. Talk the problem out. Write everything down. Structure your work. And good luck with your homework.